Our planet is a world of water, yet so little of it is available to us. The challenge we now face is profound. How do we feed a growing human family on a planet with finite resources? Our crops, the very foundation of our civilizations, are thirsty. They rely on a steady supply of fresh water to grow. They rely on a steady supply of fresh water to ripen. They rely on a steady supply of fresh water to provide the sustenance we all need to survive. This simple, fundamental connection between water and food is now under immense pressure. We must find new ways, clever ways, to grow more with less. The future of our food supply depends on it. The health of our natural world depends on it. The task ahead is monumental. By mid-century, our global population will demand significantly more food than we produce today. This is not distant, it is taking shape with each passing season. Yet the fresh water available to us remains a tiny fraction of all the water on Earth. It is a precious, limited resource. And agriculture is by far its greatest user. Farming withdraws water from rivers. Farming withdraws water from lakes. Farming withdraws water from underground aquifers. This is a simple, stark fact. Smart irrigation offers a path forward. Not magic, but practical and powerful. It lets us listen to the land, understand the precise needs of our crops, and provide water not with brute force, but with quiet intelligence. This is the story of a quiet revolution in fields around the world, one that could change our relationship with water forever. The numbers tell a story of immense scale. Globally, agriculture consumes around 70% of our planet's accessible fresh water. For every 10 liters pulled from a river or pumped from the ground, 7 go to a field. This has been the case for generations, a necessary cost of feeding humanity. Our population has grown. Our climate has become less predictable. That combination is straining the systems we depend on. It is a weight our planet is struggling to bear. Demand is not evenly spread. Arid regions face the worst strain. Semi-arid regions too. In those places, the share can climb to over 90%. Farming there is a constant battle. Sun, wind, thirst. Aquifers are being drained faster than rain can refill them. Rivers that once reached the sea now run dry long before they get there. This is a silent crisis beneath our feet and across our landscapes. The consequences are far-reaching. Draining rivers destroys habitats for fish. It also removes homes for birds. And it wipes out insect life that supports ecosystems. We disrupt the natural cycles that clean water and enrich soil. On coasts, overpumping allows seawater to creep into freshwater aquifers. Saltwater intrusion. The land itself can begin to sink as groundwater is removed. We are borrowing from the future to meet today's needs. For centuries, the primary method of irrigation has been to simply move water across the surface of the land. This is known as flood or furrow irrigation. Water is diverted from a source and allowed to flow down channels and across fields. It is a technique born of simplicity and necessity, but it is also a technique of immense waste. As the water travels, much of it is lost. It evaporates under the heat of the sun. It runs off the edges of the field, or it sinks too deeply into the soil, far below the reach of the crop's roots. The inefficiency is staggering. In many traditional systems, as much as half of the water applied to a field never reaches the crop it was intended for. A loss of 40 to 50% is common. It is a hidden tax on a precious resource. This waste is not just a matter of lost water. It creates a cascade of other problems. When too much water flows over the soil, it can carry away vital nutrients like nitrogen and phosphorus. These are the very building blocks that crops need to grow. Farmers must then apply more fertilizer to compensate, an added cost that also carries its own environmental footprint. In many regions, the excess water can cause the water table to rise, bringing dissolved salts up into the root zone. As the water evaporates, the salts are left behind, gradually accumulating in the soil. Over time, this process, known as salinization, can render productive farmland barren and sterile. Vast tracts of land across the world have been degraded in this way. Furthermore, the standing water that often results from inefficient irrigation can become a breeding ground for mosquitoes and other vectors of disease, posing a direct threat to the health of rural communities. These are the hidden costs of the old ways. It is a debt we have been accumulating for generations. Recognizing this hidden cost is the first step toward understanding why a change is not just beneficial, but absolutely necessary for a sustainable future. The history of irrigation is a story of gradual refinement. For a very long time, farmers relied on their senses and their experience. They watched the sky for signs of rain. They felt the soil with their hands. They observed the color and posture of their plants. This was, and still is, a deep and intimate form of knowledge, a connection to the land built over countless seasons. A major leap forward came with the development of drip irrigation. Instead of flooding the entire field, water is delivered slowly, directly to the base of each plant, drop by drop, right where roots absorb it most effectively. This simple shift dramatically reduces losses from evaporation and reduces runoff. It is a move from a shout to a whisper. Compared to flood or sprinkler methods, a well-managed drip system can cut water use by half, and sometimes even more. It allows farmers to grow crops in sandy soils or on steep slopes. Because water is applied precisely, fertilizers can be mixed in and delivered efficiently. Fertigation, reducing waste and cost while improving vigor. To understand how smart irrigation works, think of it as a living system with 3 interconnected layers. The first layer is the system's senses, the sensing layer. In-field sensors track soil moisture, temperature, salinity, and key nutrients. Above-ground stations measure rainfall, temperature, humidity, and wind. In-pipe sensors monitor pressure and flow to catch leaks. The second layer is the nervous system, connectivity. LoRaWAN carries small packets over long distances on little power. Where coverage exists, 4G, 5G offers reliable speed, and satellites connect the most remote fields. The third layer is the brain. A cloud platform aggregates data, visualizes it on simple dashboards, compares soil moisture with crop needs, considers the forecast, and decides, then opens a valve or starts a pump to begin a precise irrigation cycle. The adoption of smart irrigation is not driven by a fascination with technology alone. It is driven by clear and compelling results. The benefits can be measured in 3 key areas: the amount of water saved, the quantity and quality of the harvest, and the financial return on the investment. By watering only when and where needed, smart systems reduce waste. Independent studies consistently report 20 to 50% water savings versus traditional methods. Maintaining optimal root zone moisture leads to uniform growth, better quality, and higher yields. Lower water and energy costs, reduced fertilizer, and higher income can mean payback within 1.5 to 2 years for well-capitalized operations. In the sun-drenched valleys of California, almond growers have faced years of intense drought and pressure to reduce water use. Many have embraced high-efficiency microirrigation and advanced soil monitoring. Over 2 decades, the industry cut water per almond by 1/3. Individual farmers report saving 25% of their water, seeing improved tree health and more consistent yields. In the American Midwest, equipping center pivots with GPS and individual nozzle controls enables variable rate irrigation, applying more water to sandy patches and less on heavy clays, preventing over- and underwatering. A project distributed cloud-connected soil moisture sensors to smallholder coffee farmers. The initial results were promising, but the sensors were fragile and required frequent recalibration, a skill the farmers hadn't been taught. A severe lightning storm damaged a central data gateway, and the entire network went down. With the nearest technician a day's journey away, farmers grew frustrated, lost trust, and returned to traditional methods. This is a crucial reminder. Technology is not a panacea. Smart irrigation must be robust, affordable, and locally serviceable. The project failed not because sensors were inaccurate, but because human support was absent. Adoption needs training, local expertise, and deep community understanding. Without that holistic approach, advanced tech can end up as discarded plastic in a field. While potential is immense, adoption faces barriers: high upfront cost for sensors, controllers, software, and installation, often out of reach without credit or subsidies. The digital divide limits cloud-based systems. Satellite can help, but adds cost and complexity. New skills are needed to interpret data, troubleshoot hardware, and understand recommendations, requiring training, support, and peer networks. Who owns the data? Farmer or tech company? How is it secured and used? Without clear standards, trust and adoption suffer. The arrival of powerful new technologies like smart irrigation will undoubtedly reshape our agricultural landscapes. But we must proceed with care. If a farmer saves water per hectare, they may expand acreage or switch to thirstier, more profitable crops, the rebound effect, leaving total water use unchanged or higher. Automation that opens valves and starts pumps reduces manual work. While it frees time, it can displace farm labor. High costs and complexity can widen gaps, accelerating consolidation and altering rural social fabric. The technology itself has a footprint: energy, water, and minerals, sometimes from conflict zones, and limited device lifespans. We must design for durability, repair, and recycling to avoid creating new streams of e-waste in farm landscapes. A circular economy approach is essential for long-term sustainability. Policymakers must reform water governance so efficiency gains translate into real environmental savings. Invest in rural infrastructure, broadband and technician training, support models that make tech accessible to smallholders, create clear standards for data privacy and e-waste. Smart irrigation is a powerful tool, but it is only a tool. Its ultimate legacy will depend on how wisely and equitably we choose to use it, ensuring that we harvest not only a better crop, but a better future for all.